All right, so we talked about friction, and friction up to this point has been particle equilibrium. We have a small enough shape that distances don't matter, and we're dealing with friction. Well, now let's add some lengths so that friction isn't the only problem. And we're going to call this slipping and tipping. So instead of just a regular old box, what if we have a taller rectangular box here? In our given. And actually, we've already looked at a tiny bit of tipping with fluid pressure, right? We did the dam tipping. That's all that we're going to be doing here. Exact same thought process. So if I put up here a 30-pound force at an unknown elevation h. Okay, the coefficient of static friction between the box and the surface is 0.4. The box itself has a 4-foot width and a total height of 8 feet. The box is 100 pounds. And I want to find the maximum height h where 30 pounds can be applied and the box does not tip. Okay, and obviously we want our answer to be between 0 and 8 feet, because if it's greater than 8 feet, then it's no longer on the box, right? And if it's less than 0, then it's beneath the box and doesn't do us any good. Also, does the box slip? Question mark. Okay, so I have two options for movement here. One, it could be the box rotates over and falls over. Two, the box moves along the ground as it's slipping. So I have two things that I need to check here. And we are going to start with a free body diagram. So here is my box. It has a weight acting through its center of 100 pounds. It has a horizontal force of 30 pounds. It will have a friction force, and it will have a normal force of the ground acting onto the box. Okay, this acts at a distance h. All right, and I need, let's see, 2 feet and 2 feet, because the force is acting in the middle here. And then it's also acting in the middle here, 4 feet and 4 feet, right? Because this is, we're assuming this to be a homogeneous and isentropic material. So the center of mass and the center of gravity are in the same place. All right, yeah, I guess that would be more accurately G. If I'm pushing it from the left side, it's going to want to rotate over this way, which means the last point of contact is going to be that bottom right-hand corner. Okay? All right, I'm going to sum my moments about A, which is equal to 0. Counterclockwise is added to the equation. So I will have 100 pounds times 2 feet minus 30 pounds times h feet. Okay, and you're asking about the normal force. Well, normal force is the ground pushing up on the box. So if I'm imagining my box rotating, my normal force is actually going to be acting over here, which is the last point of contact, right? Because it's going to be pushing up on whatever part of the box is touching the ground. So if we're rotating about A, A is the last part of the ground the normal force is touching, okay? Otherwise, we just draw it in the middle because the box is sitting on the ground, okay? But this is a rotation, so it's going to be the corner. And I solve for H, and I get that value to be 6 3/4 feet. So that is the height that we can push on the box, and it will not tip over. If we go to 6.68 feet, it'll start to tip over, right? But is it slipping before it's tipping? Okay. Now remember, motion impends, which would be right before slipping. So slipping is where F is equal to F max, which is equal to 0.4 times the normal force, right? Because I have my coefficient of static friction is 0.4. Right now, okay, let's do this in green because it is kind of going off topic. Right now, friction, right, if I sum forces in the x direction, I have 0 is equal to 30 pounds is minus friction, because friction's acting opposite, so friction is equal to 30 pounds. Okay, it's pushing back as much as we are pushing on it. All right, and is that motion impending? Okay, well, the next thing I need in order to find F max is the normal force. So I'm going to sum forces in the y direction, and I have negative 100 pounds plus my normal force. Normal is equal to 100 pounds, which means my F max is equal to 0.4 times 100 pounds, which is 40 pounds, right? Coming down here and plugging in my normal force. So if right now the friction is 30 pounds and the motion impends at 40 pounds, then my answer is no. The box is not slipping. Okay, so as long as we keep the force under 40 pounds and under 6.67 feet from the ground, our box will neither slip nor tip.